So yeah, hi, I'm Neil. My name is on that slide, and I'm here to talk about protocol buffers, Al said. So I decided to do this talk because, like Al, when this came out, I had absolutely no idea what a protocol buffer was. And one of the best ways to learn about something or force yourself to learn about something is to sign up for a talk. Seriously, do it, because you give yourself a hard deadline, you have to do it, and you end up in front of a load of people. Wow, that went quite fast. End up in front of a load of people like yourself giving a talk. So yeah, without further ado, let's kind of dive into it and figure out why we're here. So it all started with a repo. So I was just kind of minding my own business, doing my day job, writing awesome things, working on awesome products, when suddenly Apple just kind of dropped this guy into the mix without much of a fanfare or anything. And Twitter kind of lit up around my immediate circle, and people started talking about it, and the newsletters started mentioning it, and it was all, oh my God, Apple's done an implementation of protocol buffers. To which I kind of was like, what are you talking about? But like any true Swift fanboy, I heard the word protocol. So my reactions in chronological order to the news that Apple had released an implementation of protocol buffers kind of went like this. Protocol? And my ears perked up. And then I found out it wasn't the kind of protocol I was thinking about. There wasn't some new crusty talk that randomly got released. It was something else, and I got a little sad. But then the kind of, okay, what's actually been talked about? Because a lot of people I really respect are talking about this, and I've literally got no idea. So I did that kind of thing where we jump on the internet and see what's going on. And one of the first things that really leapt out at me was this phrase. And it got banded around a bit. It was type safe JSON. And that kind of, again, really perked my interest. Because who here has been doing Swift from the early days, from day one? Raise your hands. So you all kind of remember, especially when Swift started, every single blog post was about parsing bloody JSON. Every repo was JSON parsing. And a lot of the criticism that Swift got was that JSON is asking a lot of questions about Swift. And it's asking, it's proving that it's not a production-ready language. I remember having so many of these conversations. And we all got around it with clever ways and all, but one of the things that I really want people to take away is that, in my opinion, Swift actually asked a lot of questions about JSON. And is JSON really that great for what we want? Because it is so loose. So my internet-based reactions aside, what am I actually here to talk about? So first and foremost, just straight, what is a protocol buffer? Why is it going to be useful to me, or why won't it be useful to me? What is it? Should I care about it? Then we'll go into a bit about how do we need to make it work, how the components work together, and then we're going to do a little bit of comparing it to JSON, and just a little bit on the end of comparing it to NS coding. So when I say comparisons, I really mean some quite basic benchmarking, so don't be too brutal on my data, but it really does kind of give a good idea. So first things first, what are we talking about when we mention protocol buffers? So they're originally created by Google, and it's used as the basis for a custom remote procedure call that's used for like pretty much everything at Google. Like all inter-machine communication is done through this kind of serialization, deserialization technique. So they currently have 48,000, roughly, objects defined using this messaging format. And the initial design goals were to be smaller, faster, and simpler than XML. So for some reason, I'm not sure if any of you guys can tell me, but like Google had a problem with XML. They like didn't enjoy working with it. So they set out to write something that was better. And the next line is like, it's straight from the Google developer website. It's very marketing-y, so it's a language-neutral, platform-neutral, extensible mechanism for structuring serialized data. So, you know, it's a cross-platform way to serialize your objects, and it's pretty cool. So, one of the great things about it is it kind of enables you to write out your entire application's data model, front end to back end, and just have it in one place. And it's actually composed of like a command line tool, a plugin, and a library for every language that it supports. So some of the key features is, again, I mentioned you get this single source of truth for your entire application data model. I don't mean that like just for your like iOS app. I mean front end to back end, like database to wherever. Everything subscribes to the same model. Adding new fields is really quite easy with protocol buffers. Like it's very forward compatible, so you can always add new things, and like interim systems don't really need to even care about it, and they can just pass the data along. It has a self-describing format, which isn't too great for us yet because we're not that reflection-y. But for languages like C++ and Java, they really can make a lot out of this, and they can actually take this described format from a server somewhere and adapt the code very dynamically, and we can have all sorts of discussions about whether or not that's a good idea in the pub, but it is possible. So now a bit more into the like guts. You get this kind of serialization, deserialization code automatically generated for you, which has always been a bit of a nervous point for me. I've never really been a big fan of kind of automatically generated code. It's always been something that's made me stop and go, is this right? Is this going to work like some of the time, but not all of the time? Am I going to find myself in weird situations? But that's how this works, and we're going to plow on through, and we'll have lots of great discussions as we go through. One of the really interesting things is when you create like a contract for JSON or XML or whatever, you just kind of, you have it, and the data is either that large or that small. But with the way protocol buffers are defined, you can actually be a little clever about how you define your data contract. And this can allow you to optimize it, and this can allow you to kind of shrink an already small thing a little bit more. So we'll get into a little bit more of that as we go through the talk, but it's just something to note that even at the contract level, you can design your system for efficiency. So is it something new? I definitely thought it was because I'd never heard of it before, and people started talking about it, so I was like, oh my God, this new thing. But it turns out, no, it's not. It's, yeah. They've were invented in 2001. So I'd have been 11 at that time, so that's pretty ancient. So I don't know what happened before then. And it was made public in 2008, just at the time when I turned 18 and started making some truly bad life decisions. They're already used in a few other languages. So like, just as example, we've got C#, C++, Java, Go, and please don't lynch me for saying this. I know I'm at Swift London, but they already exist in Objective-C. Objective-C did it first. I'm sorry. And there are other competitors around. So Facebook's Apache Thrift basically does the same kind of thing, and Microsoft's BOM protocols also do the same kind of thing. So it's not a new idea. It's just interesting that Apple have latched onto this. And yeah, I'm very interested to see where that goes, because Apple haven't really come up with a great answer for like the whole JSON issue. And I don't think I think even people who already knew about protocol buffers weren't really expecting them to go down that route. It doesn't seem like Apple to kind of like pick up on the Google tech, but apparently they have. So what's actually involved? Like, how can I as a developer get involved with this and make this work in my project? So first of all, we have what's called a Protofile. And this is basically the file that defines our contract. We have the Protoc tool, which is just a command line tool, and the protocol buffer framework, which is a kind of like language-specific framework that you'll add as a dependency to your application or server or whatever is going to be implementing this. So if we look at those kind of features individually, we'll start off with the Protofile, because this is where like the real meaty stuff is. So it kind of looks a bit like this. Like, this is a Protofile, and it has a few kind of interesting elements. So the first of all is just the syntax specifier. So this defines the syntax used. So there's different versions of the proto language. The latest version is version 3 that was released in 2015. The Proto 2 was released with the public release in 2008. And 3 isn't just like, oh, a bit more development on 2. They like really changed it, and they both work in very different ways. So Swift actually has support for both Proto 3 and Proto 2. But most people would try and argue to use the latest ones because they change things for good reasons. And here we have a message declaration, and this is where the important stuff starts happening. So a message is basically an object, is the easiest way to think about it. It could be determined as a class or a struct. It depends on the language. So like, Java's going to interpret this as a class. Swift is going to interpret it as a struct. They kind of contain several fields that are human readable. So you can look at this and, you know, this is very simple for people like you, because you're programmers, and this should make a lot of sense. You've got a type, you've got a field name. The only kind of interesting bit is the tag we have on the end. So we have these numbers, this 1, 2, 3, or whatever, and these aren't values. These are literal tags, and these are what are used to identify our fields in binary format. So no two fields can have the same tag. They need to go up sequentially as we add things. And this is where we can kind of start to get a bit smart about how we represent our data. So if we look onto the next section here, we have nested objects, arrays, dictionaries, and optionals. And a lot of this is fairly self-explanatory. The optional keyword specifies nullable type. And 10 points to whoever can guess as to what kind of object that is in Swift, like an optional. Repeated denotes an array. And the tag for the repeated object here is 3. And if we had a very large array, each element of this array would get tagged with this field of 3, which is really cool because it's a really small integer. It's a really small, easy way to define it. But as we add more and more fields to our message type, it makes sense to think about how we structure our data, because actually we want all of our repeated fields to have just integer numbers that fit in the integer spectrum and can be represented as like 8-bit integers. As the numbers get larger, they actually get more expensive to represent, because obviously it takes more memory in binary to represent a larger number. So this is some of the kind of optimizations that we can start to bring into our project just at the contract level. And the last kind of important thing to take away is, for the whole forward compatibility thing, once you add a field, that field exists in your object, and serialization, deserialization in applications that consume this object will fail if you change the field or if you remove it, because they are expecting it to exist in that format. So it does require a little bit of forward planning as you make your objects, kind of reserve some keywords or reserve some tags for potentially expensive objects. The next thing is a command line tool, which can be installed by grabbing a pre-built binary, or if that really offends you because you're a real programmer and you have to build everything from source, you can go onto GitHub and build from there. The Swift plugin, you actually have to clone from GitHub and build using Swift build and add the resulting executable to your path. And then we can now run the Swift plugin. So we've defined a Protofile with all of our fields. We can run the Swift plugin and actually generate our entire application's data model just with the following fairly boring command, which, so the Swift out just says we want to use the Swift plugin. If you're doing this in Go, you'd use the go out, and that would use the Go plugin. And the my.proto just determines the name of the data model. So this command here will produce a file called my.proto.swift, which will contain your entire data model. And the Swift plugin, which you may have guessed by the fact it's built using Swift build, is actually written in Swift, which is pretty nice. It's if you have issues, you can go fix it, so get involved. So when the command line rule is done, we're left with this data model .pb.swift file, which contains our entire data model. In Swift, every message type that we saw before is created as a struct. And one of the slightly interesting design decisions here is that every struct is given a default value for every property. So every field is given a default value. So if you define a string in your Protofile and you create one of these structs, it's got an empty string as its default value. And you've got, wherever there's an integer, it's got a default value of 0, which is a little interesting. I found it a bit jarring when I first started working with them. And there's a few, like there's a convenience function for equality, so you can like test if one's equal to the other, and it does all the kind of checking each property's equality. And it also generates a couple of functions that are used by the Protofile framework for serialization and deserialization, which, to be honest, you shouldn't really have to interact with, but they are there. The framework itself is literally all about deserialization, reserialization. It can be installed using CocoaPods or Swift Package Manager if you're writing fancy server-side implementations, because why wouldn't you? This is a great way to talk from your Swift server framework to your app. And the main methods we care about are, like, these are pretty cryptic, and I'm sure you're going to have a hard time figuring out what they do. But don't worry, there's an example coming up, so we'll get through it. So we have an initializer with some data, which will take in some protobuf data and turn it into an object. You can serialize it into that same kind of data. And weirdly enough, you can serialize it into a JSON string. And I haven't quite figured out why they add this. And if anyone could tell me, that would be fantastic, because it is keeping me up at night. And here's the point in the talk where I was like, right, I'm going to break out into a demo, and I'm going to show everyone how this works in the real world. And I wrote the demo and kind of went through it and rehearsed the talk and realized I had created possibly the most patronizing demo in the history of London iOS meetups. So I'm going to, instead of patronizing you all with a demo, I'm just going to show you a slide which contains the entire demo, which really upset me. But let's go through this. So yeah, I've created this my library type using my Protofile. I've run my command line tool. To create an instance of it, I initialize it as normal. The properties are all mutable. And again, this is one of the things that I found slightly jarring about using this framework. And yeah, in this case, I'm serializing JSON because I made a slight error on my slides and meant to write serialized protobuf. But either way, serializing data is super simple. It can throw an error, but you can deal with that with normal error handling. And you literally just write that line. And to initialize with data, we just, again, throw the data into the initializer, and it just works, provided it doesn't throw an error. But again, we can worry about that later. And I see a few of you muttering, yes, deserialization, serialization are the wrong way around on that slide. I noticed 3 seconds ago. But anyway, when we talk about something like this, there's pretty much the only thing people actually care about or interested in is, like, how does it stack up against something like JSON? So we can actually cut to the interesting, meaty part of the talk now. So even though the original design goal was to replace XML, and I could have done a lot of talking about what's the difference between using this or using XML, I believe most of the people in this room actually care more about JSON and what's it like using this compared to using JSON. And it's interesting, for debugging, JSON is so much more useful because it's readable on the wire. You can proxy between your server and your application and just see the data in a nice usable format and go, oh, I realize why that's not working or whatever. But when you try to do that with protocol buffers, just because it's sent as binary data, you just get a load of binary data back, and it's just not interpretable to you. That being said, JSON comes with its own downsides of actually having to deal with JSON in your application. And it's larger and it's harder to optimize. And then back on the other flip side, protocol buffers add, like, you have to have a third-party dependency to interact with them. That being said, most people add a third-party dependency to interact with JSON as well, so we might take or leave that last point. So we get onto the showdown. So this, again, is some very basic benchmarking I did. But the battleground for this is this faithful 2-year-old MacBook Pro. And so we're going to look at object serialization, deserialization, JSON versus protocol buffers. And this is what we get. So in the blue, we'll see the time taken for protocol buffers to serialize the number of objects, and in green we see the time taken for JSON to serialize the number of objects on this rather old laptop. And the left-hand side of the chart, I'll admit, is not the most interesting graph you'll see this year. But it's important to me because it really shows that on those, for those number of records, this question is really kind of a moot point. Like, they're both ridiculously fast. It doesn't matter. But when we start hitting the 1,000, 10,000, 100,000 range, that's when we start actually seeing some real noticeable difference. And just hands down, protocol buffers just easily destroys JSON for object serialization. And then when we move on to deserialization, it just gets even worse. And I'll admit, this was like not run on the fastest of machines, but all the code was run on the same machine. So what's important to take away here is maybe not the actual values, but the relative difference. And you can see that when it comes to deserialization, we're actually getting slightly better performance on protocol buffers for 100,000 records as opposed to 10,000 records of JSON. And that's actually quite significant if you're working with large data. So yeah, I'll just leave you with that and let you draw your own conclusions there. And the last thing I'm going to talk about is local persistence. So protocol buffers weren't just designed for the networking layer. So one of the questions that Morgan now asked me when I first pitched this topic was, what's it like compared to NS coding? And I had no idea. So I decided to try and find out in the same way, because I think we're all in agreement that NS coding just doesn't, it feels off in Swift. Like, it doesn't feel like the right thing to be doing, and just nothing seems to have come from Apple on a better way to do this. And especially like NS object on your data model objects, like, really puts developers off using NS coding. So, and going around other methods or using wrapper objects. So I wanted to see if maybe this could be a bit of an alternative to NS coding. Like, if it had the same kind of results as it did against JSON, that'd be fantastic, wouldn't it? So again, we have another showdown. It's exact same rules as before. And on serialization, yeah, we're taking, like, up at the higher record numbers, we're taking, okay, admittedly not that much longer, it's only about 2 seconds longer, but we are seeing a really increased performance for protocol buffers. But when it comes to deserialization, NS coding is actually consistently just that little bit faster, which was kind of disappointing, but probably quite predictable as well. I didn't see anyone looking horrifically shocked. So as something to replace NS coding, it's probably too much of a dependency to bring into your project and maybe not the best idea. Like, feel free to try it and please let me know how it goes, because I'm not going to try it. But my general thoughts on it is it wasn't love at first sight. Like, I don't like generated code in general, and like the generated objects with their whole default values and everything being really mutable didn't feel quite right to me. But it did remind me of other languages where you'd like create an object and decorate its properties, and so I could see why the implementation was done the way it was. That being said, not having to do any parsing logic talking between a server and an app was amazing. Like, that felt like a complete breath of fresh air to me. Like, it was just so quick to get up and running, so easy to do. And the last kind of thought is it made me think about the way I write Swift quite a lot, especially the fact that the generated objects didn't feel Swifty to me, because at some point I see what they're getting at, that maybe the data model shouldn't care about mutability and immutability, because with a struct we can always define that by declaring a struct as a letter or a var and things like that. So maybe it's up to the thing implementing it to define the immutability or mutability of an object, not the object itself. And I'm not sure I'm 100% sold on that, but it really made me start questioning everything I knew about Swift, which was the best thing I took away from doing something like this. Because the more questions we ask ourselves, the better we get as developers. So personally, am I going to use it on a project? It's not up to me. A back-end developer is going to decide if I'm going to use it. And if I was writing a Swift backend, because that's what we're all going to be doing, lads, money in that, it's probably not my first port of call for something to use, but it's something I might think about. But check it out, check out the repo, and like disagree with me and tell me why I'm wrong for suddenly considering this new way of like thinking about Swift, or tell me that I'm an idiot for not seeing it from the start. Like, it's all good conversation to have, and it's why we should always be like pushing ourselves as developers. So the best thing that came out of this project for me was me just thinking a bit more about what I do personally. It's not something I'm going to be using going forwards, but if it helps anyone else out here, that's fantastic, and I've learned a lot. So thank you very much, and are there any questions?